Good evening, everyone. So again, I welcome you all in the second day of the AICTE ATAL FDP. We are going to start with the next session for today's FDP. There will be two sessions every day, and on the last day we will have three sessions, starting in the afternoon with and in the evening. So before I welcome Lalit Pant sir, I would like to inform you all Lalit sir has been a key motivator for us for organizing different workshops, seminars, and we have been interacting with him for a long time. Lalit Pant sir is a experienced, learned engineer. I must say he is a founder of Kojo and Kojo-AI, and you will be delighted to hear from him. Now, to formally welcome Lalit Pant sir, I request the session coordinator to welcome the guest of the session.
Good evening to everyone again. Now we have our second session of day 2 of our workshop. So for the second section, we have Mr. Lalit Pant sir from Kogics Foundation. Lalit Pant sir is the founder and managing trustee of Kojo, an open source learning platform that helps children develop computational thinking, design thinking, and core learning skills. A graduate of IIT Kanpur with a postgraduate degree from IIT Delhi, Lalit sir has extensive experience as a software architect and educator, having worked in roles from junior programmer to CTO across the US, Europe, and the India. He is passionate about teaching programming, AI, and meditation to young learners and has authorized articles for renowned programming journals like Dr. Dobbs Journal and Java Reports. His open source contribution includes projects such as Kojo, Tefla, Jiva, Kojo AI, and Kojo Music, reflecting his dedication to creative learning through codes. Now, will continue the session.
Thank you for the very kind words and good evening to everyone. Uh, Let me just cross check one more time. Is my screen visible fine?
Sir, please share the screen again. I
Okay.
think
Okay. Let me do that. Perfect. That's good. Is it visible
now it's
now?
visible, sir.
Okay, so let's get going. Uh, Topic for the day is prototyping AI applications from
Sir,
concept to
may I request you to please turn the full screen mode of the presentation, if possible,
uh,
sir.
let's see. Okay, let's see. Is that a little bit better? Is that a little bit better or let me see start present.
It's
Okay, is
it's
that
better
better?
now, sir. It's better now, sir.
Okay.
Right. It is absolutely right, sir.
Okay, great. So I'm sure we've already I'm sure you guys have already gone through the basic concepts of design thinking potentially yesterday. So I'm not gonna spend too much time on this slide. We know that design thinking is made up of these 5 phases, in a very loose, flexible way. The creators of design thinking always say, hey, don't get bogged down by the terminology and don't try to be very precise about these things. These are broad guidelines on how to do things. So we have empathize and define, where you get close to a user and figure out what problem you want to solve as something that will add value to the user. And then you have ideate, prototype, and test, where you come up with solution ideas and then see make those ideas real and see how much value they provide to the user. And then the ones that work well, you take them forward, and then you iterate on this process. So that's the broad kind of description of uh, the well-known way in which design thinking is presented as the set of 5 phases. I would like to also talk about it from a slightly different perspective, where I want to simplify the idea very drastically, because at its essence, the idea of design thinking is pretty simple. And the idea is that design thinking is a way of coming up with ideas and seeing whether they are any good for users. That's basically what it is. You come up with ideas and then you see if they provide value to the user. And that's the bottom line with design thinking. So one good way to rephrase what I just said is, if you think about a user to whom you want to provide some solution. So there's a given user, there's a given context, and then there's a problem and there's a solution for the problem. So while figuring out the problem, you want to first diverge. Diverge means you come up with ideas. Come up with many ideas. Don't fall in love with your first idea. Come up with as many ideas as you can. And then you converge in terms of, from all the ideas that you came up with, you select a few based on very clear criteria. There should be clear reasons why you want to select a few ideas. Those clear reasons could be discussions with the user, whiteboarding, drawing stuff out for the user, walking them through, scenarios of what you're talking about in terms of your ideas, and things of that nature. And then you converge on a problem that you want to solve. And then you go into the solution space, and again you diverge, you come up with ideas, and then you prototype those ideas, and those that seem to provide value, you converge on them. So that's the broad kind of play of the design thinking process. Okay, so with that backdrop, the goal for this session is that how one can take a rough, let's say, an AI idea, because this FDP is about AI. And very interestingly, this whole presentation that I'm giving you, uh, over the last couple of months, it just so happened that I happened to get pulled into a prototype where we started with the thought that, hey, these days AI is getting very powerful. So where should we apply AI? So we essentially, started with this precise question, that we should use AI to provide good value in some domain. And now let's think about what we can do. So this, over the next 1 hour, the session that we go through is actually a very real case study with all its non-idealities and all its, issues and obstacles and learnings that we had, and hopefully some good things also. So we took up this idea that, okay, we want to use AI to provide value in a domain. And then we kind of decided that, hey, how about if we provide value in the domain of agriculture, because that seems to be a very useful domain. So we want to go into intelligent agriculture just to do a proof of concept, to see where it would lead. If it would lead to a startup, wonderful. If not, we are anyway in the space of education. So whatever we do, we're going to have good good collateral, good projects, good material, good problems to kind of think richly about the usage of AI in real systems. Are we doing fine on the audio? Is everything going fine?
Fine, sir. You are audible, sir.
Okay, great. So then we took this idea and then we said, okay, let's follow a design thinking process to narrow things down to a specific user, problem, and context, and generate ideas and evaluate those ideas, see how good they are, build some prototypes, put them in front of users, see the ones that are good, flesh them out, And then, at this point, we are basically at the point where we started from a concept and we almost have a fieldable prototype. A little bit more work needs to be done, but we are very close. And then we will talk about the journey of, how the design thinking process helped us do what we wanted to do. And then, of course, we want to kind of generalize a little bit and see what patterns we can extract from this process so that you can use them in your AI prototype ideas. So that's the goal for this session. Now, one potential point of confusion that that I ran into when I started thinking about creating this deck of slides was that when we talk about prototype, which prototype are we talking about? Because here we are talking about prototyping an AI application, and design thinking also has a prototype phase. So what is the relationship between this AI application prototype and the design thinking prototype phase? And in my mind, design thinking prototypes are very small and quick and lightweight, and their whole purpose is to see if the ideas that you generate are any good. Okay, so design thinking prototypes are much more fine grained, and then out of the ideas that you generate and you prototype, some will look good, and then those will become features in a fieldable prototype, because a fieldable prototype is a much bigger thing. A design thinking prototype, you should not spend more than a day. Could be a 10 minutes, could be an hour, could be a day, just to put something together, put it in front of a user, get some feedback, see what value is there, compare different ideas. And then the ones that look promising, you kind of flesh them out, and then they become fieldable features in a larger prototype that you can put in front of a user for a few weeks to see how it works in a real life kind of a setting. So in terms of the terminology, I broke this down into ideation prototype versus fieldable prototype. And the purpose of an ideation prototype is to evaluate an idea, because remember, design thinking is about generating ideas and evaluating them to see if they are any good for the user. So the whole purpose of the design thinking prototype is to evaluate the ideas that you generate. For a fieldable prototype, the purpose is more serious. It is to validate a feature in a real context over some longer period of time. Okay. And then in terms of the fidelity of the idea that the prototype captures, uh, the ideation prototype just has enough to basically answer the question of, okay, what you're trying to do, is it valuable or not? Whereas a fieldable prototype, the fidelity has to be, much more. It's got to kind of run all the way through the system. It's got to be much more production ready, because it's going to be in front of a user for 2, 3, 4 weeks. So the robustness, the fidelity of the fieldable prototype has to be much larger. Then the time with users, an ideation prototype, minutes to hours, is just like a quick thing that you do to evaluate the idea that you come up with. But for a fieldable prototype, which you can call a pilot or an MVP or a pre-MVP, I would actually call it. But almost like an MVP that you're putting in the field, that's going to be there days to weeks. So that's the timeline you're thinking of in terms of a fieldable prototype. And spending that much time in front of a user is a fine thing to do, because it's come in through a process of where many ideas have been evaluated and some have seemed valuable and they've been fleshed out, and finally they make it into a fieldable prototype. So now you are at a point where you think you have some useful, valuable functionality for a user, and you really want to put it in front of a user to see how they're using it, what problems they're having, what data is missing, what logic is missing, what AI enablements are missing, etc. Then the scope of an ideation prototype is very focused, just one particular idea that you want to evaluate. The scope of a fieldable prototype is much larger uh, because it's a full slice through the system. It has to integrate with other slices through the system. It has to integrate with whatever user workflow is going to be the user is going to carry out as the prototype sits in the field. Then the next item here is the data that the prototype works with. For an ideation prototype, data can be lightweight. It can even be mocked. If no real data is available, you want to see, okay, how data is going to flow and what kind of UI can provide what kind of value. You can even mock the data. Whereas for a fieldable prototype, data is much more real. It's going to be data that gets collected over the few weeks that the system is running. It's got to be stored safely and then analyzed, etc. So the data is much more serious in the context of a fieldable prototype. Then the UI fidelity for an ideation prototype needs to be very little. It just should be enough to test the idea. For a fieldable prototype, it needs to be at least minimum viable usability. And I'm going to talk about this point more later, because if you read up about design thinking, you will get the impression that it's all about the UI. Uh, and in the case of a working product where just the UI was messed up and then somebody did a design where the UI unlocked the real value of the product, that would still be the case. But if you're building a system from scratch, right from a prototype to an MVP to going up to pilot and production, then the UI fidelity story is a little bit different as I see it. So that's an important point which we will talk about later also. And the outcome of the ideation prototype is just a decision of, should we keep this uh, and flesh it out for the fieldable prototype, or should we kill it because it doesn't provide value, or maybe we can tweak it a little so that it starts to provide value. And if we keep it, it becomes a working slice in the fieldable prototype, a slice through the system where multiple such slices come together to make your fieldable prototype. And with the fieldable prototype, once it's up and running, then the decision, the outcome is go, no go for an MVP, and then roadmap, architecture, and implications, etc. Okay, so I've spent a lot of time talking about what exactly we mean by prototype when we talk about prototyping AI applications from a design thinking perspective. And I hope that these thoughts make sense. And in fact, let me also say, backing up a little, that even this talk itself is kind of an example of design thinking, because here we are saying that we are generating ideas, right? And of course, I went through a few iterations where I thought, okay, let me generate some ideas. And then I thought this seems to make a little bit of sense. So now I generated these ideas and I'm now evaluating it with an audience to see, okay, does it really make sense or not? So that design thinking philosophy and approach is working uh, at the level of this presentation itself, if you kind of see what I mean. Um, okay, so moving on. Given that this is a talk about building AI applications, let me just spend a minute talking about uh, one very important decision that one needs to always make when you think about introducing AI into a system. And that is that what is the impact of AI going to be and what is the cost of AI going to be? And some of these ideas, of course, are, come from the backdrop of machine learning. Because maybe these days it's no longer a choice where you evaluate whether it's worthwhile to incorporate AI or not, because the buzz is so strong that you absolutely need to. But then even if you do want to, you still want to be able to look at the impact and the cost. And the impact of the AI feature is going to be good if it can replace, first of all, if it can replace a complex part of the system that is difficult, time consuming, and error prone to build or maintain. So if you have some system which is, I mean, within your larger system, if there's a subsystem, like for example, a rule-based subsystem with like hundreds of thousands of rules, etc., uh, then that kind of a complex thing which is difficult to enhance and maintain is a good candidate for handing over to AI. Or if there is good benefit in getting mm, inexpensive real-time predictions, that might not be perfect, but that are good enough. Then that is also another place where usage of AI is a good thing to do. And once again, this is when we say AI, this is more from the kind of pre-Gen AI kind of machine learning that we are saying these things. Uh, now, but even with Gen AI based solutions and even with agentic solutions, I think it's good to evaluate, okay, what's the impact going to be and what is the cost going to be for the impact that we are getting. And the cost, of course, is influenced by the difficulty of the problem, the cost of the data, the cost of the training and inference, the need for accuracy, the cost of the people involved. Right. So even with Gen AI solutions, agent-based solutions, you need to have good evaluation criteria for, okay, if we are doing this, and there are 5 different ways of doing this with 5 different LLMs, some proprietary, some open source LLMs, and then these are the different kind of agentic workflows we can set up, or we can write our own set of workflows that we want to do with all these technologies. But then how do you know that a solution is good or not? Uh, and then if things change, how do you know that there's no regression and so on and so forth? So then you need good evaluation suites to be able to do all of that. So there's that cost involved in trying to come up with a reliable solution. So this is something you want to keep in mind, the impact and the cost. Okay, I'm going to skip over this one. So then we come to mm, the kind of the meat of what I hope this session is going to be able to kind of generate some ideas uh, for you with, and that is 5 solution patterns that we saw as we kind of went from concept to a fieldable prototype in the domain of intelligent agriculture. There are these things that we kind of saw that were happening, and I've just listed them down as some good takeaways or good food for thought for similar systems that you might build for yourself. Uh, and the idea is that we will walk through the case study of what we did, and there on the slides we'll mark which patterns are appearing, so that in the midst of the details of the case study itself, the higher level ideas also seem visible, gain visibility and surface up so that we can potentially benefit from them in different contexts. So the first solution pattern that you will see is data/logic before models, because an AI prototype or an AI application is never going to be AI only, right? It's going to live within some workflow where some data is flowing, there's some logic, and then one complex or one important part of the system is being handled by AI. So as you build out this system, I think it's good to focus on the data and the value that you can extract from just the data and some simple logic, or even maybe not so simple logic, just to set a baseline for what the AI system needs to beat. If you want to evaluate the impact of the AI system, then okay, without the AI, what can you do? And then you say, okay, this is a very simple baseline, and then our AI system needs to at least beat this baseline uh, for it to be a viable thing for us to do. Because some of these regular software engineering things are much easier to kind of nail down and build reliably. So it's always a good idea to start with that kind of a baseline. The second pattern is from ideation prototypes to fieldable features. And we talked a little bit about this when we talked about prototypes. So the ideation prototypes are these quick throwaway things that you come up with ideas and then do the ideation prototypes. And the ones that are valuable, you kind of promote them so that they become a part of the fieldable prototype and live in the field for a while with real users. Uh, so that you could then, of course, start that cycle again, right? Once the fieldable prototype has been running for a while, then you would, because design thinking is an iterative process, then you start the whole thing again, all over again. You see, okay, uh, have we learned more about the problem? Do we want to redefine the problem a little bit because that adds more value? Then you ideate, you prototype once more and so on. So this iterative cycle of things keeps going on till the point where you say, okay, this is a good enough cut to release a pilot or an MVP or a product. So that's the second pattern. The third pattern is usability and learning versus UI fidelity. Uh, and that ties into one of those rows on that prototype slide which I was talking about. So this is the basic idea of form versus function. As you define a context and a set of users and define a problem for them, and then start defining solutions, I think you need to first focus on the function of what is that solution doing with a minimum usable UI. So in the initial phase of the development of things, usability and learning is more important. And then as you progress further and further, where the functionality is more nailed down, then the UI fidelity can get better and better, and different ways of using that functionality can be presented so that the true value of that functionality is unlocked. So that is another pattern we will see. And I think I'm running rather late because it's already 30 minutes, right? So I have maybe 50 more minutes to, it's 8:04, so yeah, a little less than an hour to go. I think I need to keep track of time because there's a bunch of slides that I need to cover. Okay, so the next one is edges before center. That's the next pattern. And this is about looking at the data flow and the workflows in the system. Uh, and getting an architecture for the system right to unlock value for the user. So see how data is flowing end to end, and what the architecture of the system is looking like, what it needs to be to provide value. So this is that aspect of things. And then the final pattern is borrowed brains before custom models. And that is the idea that, okay, once you start plugging AI into the system, these days, of course, it's always better to go with off-the-shelf models and LLMs, VLLMs, APIs to get a useful baseline on what the AI can do with the problem that you're trying to solve, and uh, only then decide if you want to train a custom model or do custom fine-tuning to unlock even further value. So these are 5 patterns we will see today. So these are 5 solution patterns. These apply more to the ideation, prototyping, testing phase of things. And then there are 2 process patterns we'll see all over the place, which is the core of design thinking, which is come up with ideas and then so diverge and then converge. Come up with ideas and see if they're any good, and then choose the ones that look good for very clear reasons, whether it's like a prototype or whether it's a discussion or a storyboard or a whiteboarding or whatever. And backing up just a little, so we are talking about 2 processes here. There's this macro process of design thinking, which is empathize, define, ideate, prototype, and test. And then within each of these, there's a micro process of generate ideas, evaluate how good they are. Never fall in love with your first idea. Okay. And then there's an even deeper message, which is don't get hung up on the terminology. Make the process your own. based on this very simple core idea, which, to repeat, is that design thinking is a way of coming up with ideas and seeing whether they are any good for users. Okay, that's the core message, that in any context, generate some ideas and see if they're any good. Evaluate them in a very concrete way, and then pursue the ones that seem to add value. Okay, so over the next 1 hour, we're going to be uh, going through this kind of a roadmap. So part one, we are already pretty much done, which is the broad framing of what design thinking is about and what we are about to do. Part two is the case study journey, and then part three is our learnings from the context and the background and the case study, and uh, distilling of the patterns into some practical guidance that you can use for your own AI prototypes. That's the intent. Any questions till now? Are we doing fine? Is what I'm saying making sense? This is my first evaluation I'm asking you in terms of the design thinking process. I came up with these ideas, and I just want a quick eval, hey, is it making sense, or okay, somebody said no, it's not making sense. So it would be great if I could get them. Okay, but they do seem to be thinking it's fine. Okay, that's I'm taking that excellent to mean that they're on board with what I'm saying. So that's good.
Sir, sorry to interrupt. We have a batch of more than 200 participants from
Uh-huh.
different fields.
Uh-huh,
Most of
uh-huh,
them are obviously from computer science or artificial intelligence field,
uh-huh,
but
uh-huh,
some of the participants are from linguistics, some of them are from management, some of them from our different departments of the different universities. We have
okay,
participants from around 30 institutions throughout the India.
okay, wonderful, wonderful. And is my message clear to even those kind of participants?
Yes,
Or
yes, the
you
message was clear, and every one of you, the participant was able to understand it, I guess. And please use some more examples during your session, sir. It's a
Yes, yes.
suggestion, sir.
Now we are stepping into the territory of examples. In fact, over the next 30 minutes, there are going to be so many examples that you'll probably get sick of the examples, but that's the territory we are stepping into now. We are looking at the case study journey of what we undertook over the last couple of months. Okay, so so in the context of the thought that we should use AI to try to build something of value in the intelligent agriculture domain, we we kind of got in touch with this farm owner in the hills who works in Delhi but who shuttles back and forth to his farm in the hills in Uttarakhand. Uh, and he wants to give up his city job and return back to his village for a variety of reasons, wanting to promote his cultural roots, wanting to live a much healthier life, better environment, much more healthy environment away from the pollution, etc. Now, wanting to stay connected with nature, wanting to utilize the abundant resources, so much land, so much resources available. So we got in touch with this gentleman, and then as we discussed things with him, this larger context emerged about declining livelihood avenues and rising youth migration in the hills, this Palayan problem. Uh, because agriculture is the main avenue of employment in the hills. And if agriculture is difficult to do, then everything else suffers. And currently, agriculture is difficult to do because of a variety of reasons. It could be things like the climate, uh, the threat of animals on the fields. Because whatever crop you plant, there's a lot of animal presence where animals come and eat things up. Then the logistics, availability of labor. Then the farm being a distance away from the road. So how do you get produce farm to the road, then transportation, going to the different mandis, just the whole supply chain, all of that's it's a complication. So agriculture is not smooth in the hills. And then because agriculture is not smooth, then livelihood opportunities are on the decline, because agriculture is the grounding force that holds the most potential in the rural hills of Uttarakhand. But if we can make agriculture better through the use of AI, that was the thought, then that can be a backbone for some very, very interesting things like agri-tourism, other forms of tourism like spiritual tourism, yoga tourism, then food processing industries, and so on. Many other things can happen if a good infrastructure um, uh, comes into place based on the foundation of strong agriculture in the hills, including software development centers. Once the infrastructure is there, then the thought that, hey, we have these little centers all over the place where software development could happen. So that this was all part of the discussion with the user and some people that he introduced us to. Then after all of that discussion, we said, okay, it's clear that, if we can do something good with agriculture, then we might do something very interesting here. So if we can use AI to make agriculture better in the hills, that is a worthwhile problem to try to think about. And then we, went into details of, what are the challenges in the if you want to do agriculture in the hills, then what are the challenges? And I will not go into a lot of detail into this because, we're running out of time here in terms of the number of slides I have. But broadly, it's it's things like, uh, so at the center of the thing is the crop cycle where the crop is grown. So then what to plant, and then how to make it grow well, and then how to get it to the market. So that at the end of the day, it's a good economically viable proposition. So that's the basic problem you want to solve. So then we kind of dug down into, okay, what are the different aspects of this problem? So we went into all of that, uh, went into more detail into trying to define the problem. And then we said that, okay, this is a large problem. So let us kind of converge on, because we've already done the divergence here, so uh, keeping in the design thinking thought about, diverge and converge, generate ideas, and then pick ones that look valuable for very clear reasons. So we kind of looked at all the options, and then we finally said that, okay, that crop management for cauliflower, phool gobi, as a core operation that can be made better. If we can do that, then we can make a start in this domain. Uh, and the criteria for this decision, which is very important, right? Because we said you have to converge with criteria. When you come up with ideas and then you select some ideas, there have to be clear reasons why you select those ideas. So so the reason for selecting crop management for cauliflower was that, first of all, crop management is the core, phase in this whole thing about, generating value from agriculture. So that seemed clear enough. And then cauliflower turned out to be a good plant for a variety of reasons. So that we came to the conclusion that if we can do it with cauliflower, then we can do it with pretty much, any kind of a plant, because it has enough richness, enough complications to provide a rich ground for us to play with all kinds of things, with data, with logic, with computer vision, with AI, Gen AI, etc., etc. So so that's what we did. We kind of defined this as the problem that we want to take on. And then we started thinking about, okay, what for this problem, what kind of solutions we can generate. And here's just a quick pictorial view of the scenario, so that hopefully it makes more sense to you. So we have this field with multiple beds, And then we have, for example, a water tank, and there could be like fertigation tanks also, with nutrition, different nutrition components in the different tanks. And then there's a pipeline coming in with a valve in the middle, and then the pipe goes, and then there's drip piping on all the beds for the crops. And then you can have a soil sensor. You can have multiple soil sensors in the beds to kind of tell you what is the moisture, what is the nutrition level of the soil. And then you can have cameras to kind of give you pictorial views of things. Uh, and then you can have weather sensors to tell you, okay, what's the weather like? Has it rained? Is it going to rain? uh, what's the sunlight like, and so on and so forth. So you can have a weather sensor also. And then all of these sensors can feed into a dashboard, for example, where you can see uh, all the data of what's happening in the farm right now. Uh, and that happens to be the first solution idea that we had. So, there were these four solution ideas. So live dashboard for monitoring, just giving visibility into what's going on in the farm. And then the second solution idea was, okay, uh, so to take it a step further from just visibility, if we can take some actions which are very, very useful, like, in a hill, uh, if you want to turn on the water to the beds in the field, then it might be, you could actually be in a situation where if you step out to kind of turn on the water, there could be a threat of a leopard coming and attacking you. So, uh, as you know, like an extreme example of an impediment to turning on the water. And then, of course, the other impediments would be that there'd be steep slopes, etc. And so, you can't just walk over all the time. After in the evening, you have to be very cautious, and so on and so forth. So, an automated solution provides a lot of value there. Then animal deterrence is, of course, very important because that is a big threat in terms of the crop cycle. And then the analysis decision support, with all this data coming in, can we do a good analysis with things like AI and do decision support? So then with this kind of infrastructure in the farm, the sensors, the actuators, the valve being the actuator here, you can have a dashboard, and then with the data coming in, you can do some decision support. Uh, yes, you can use solar pumps also, absolutely, so to make the farming operation more economic, more environmentally friendly. You can absolutely, and you should use solar power as much as you can. So, so you can, with all the data coming in, you can do dashboards, you can do decision support, and then you can have a control center in your app, where you can control things. So, for example, there you can turn the valves on and off so that nutrition and water flows into the beds where the plants are. So that's the broad context for things. So that was our ideate cycle for, okay, given the problem that we've taken on, which is crop management for cauliflower, these are some things we can do. And then we said, okay, let's just start with the dashboard first, because the first step is, let's just gain visibility into what's going on. And that's valuable enough, because instead of a black box where we don't really know, how things are playing out, if we have fine-grained visibility into what's going on, how the soil is looking, what the animal presence, the nutrition levels of the soil, then even outside the system, we can make good decisions as human beings, because we have some very useful information coming in, and we can just choose to make good decisions even outside the software system. Just by providing that live data, the software system provides some value to the human user. And then we talked about these four kinds of inputs that could be coming in. So soil sensors, weather sensor, cameras, and even manual data entry. The people going into the field, if they could enter useful information, then that information could be correlated with other things too, uh, to to kind of provide value from the dashboard. And we're starting to see the labels for the patterns coming into the slide. So the pattern here we are seeing is data slash logic before models. So pattern number one. So just get some data and some simple logic without worrying about any models or AI or things of that nature. And this can start to provide value in a real system that you're building, where eventually the goal is to get AI into the mix. Then we focused even more. We said, okay, let's just go to soil sensors and cameras. Let's just make a very concrete start. Let's get something going. And this is a good set of things for us to think about the space and learn more about things. Then we kind of converged, looking at a few things, we converged. Soil condition monitoring can absolutely be done with AI, and we'll talk about it later as we go further in the presentation. So we converged onto the following tech stack with the guiding constraint that it should support AI well, should be one language if possible. It should not be that the UI is in some other language, then the server is in some other language, and messaging is in some other language, database stuff is in another language, AI is in another language. So let's not get into all of that if possible. If we have a good solution that works across the board, then let's try to go with that. And we found that this seemed to be a pretty workable solution. So Python, then Gradio for the UI, Fast API for servers, SQLite as the database, PyTorch for AI, Pandas for analysis as needed. And the pattern here, of course, is still that, we are still working in the context of, hey, to begin with, let's just get some technology in place so that we can put some data flows and some logic in place before we, go into the models, etc. But then the architecture should support whatever we want to do, and should make it easy for us to kind of scale the team also a little bit so that, if it's one language that everything's happening in, that makes the team aspects of things and training, etc., much easier. And then pattern two coming in here being ideation prototype to fieldable feature. Okay, so here the idea being that, okay, with this tech stack, let us get things running, and let us get things in shape where this will be fieldable in the future for our fieldable prototype. So then what we did was, we kind of built this little thing where you have an admin area where you can set up farms and fields and devices and device assignments, devices being things like, soil sensors and valves and so on. And then you could go to the devices tab and, for the various devices, or, well, you could see what the devices are, you could set up the devices, you could create new devices, and then you could go into the dashboard and see, okay, from these devices, what are the readings that are coming in? And the pattern there was user interface usability as opposed to user interface fidelity. Just focus on data flow and, things coming in, and some basic usability on, okay, if this is looking bad, make it red. If this is fine, make it green, etc. And pattern 4, which was edge before center, which was about the architecture of the system, that was also starting to come into the mix. And then once we did this, the learning was that the stack is workable, system architecture is reasonable, and it's a good foundation for further divergence exploration of ideas and solutions. And we saw a lot of potential complications also. Workable soil sensors at a reasonable price, given our focus and our team size and our skill set. These sensors can be anywhere from 15, 20, 40, 50,000 rupees. And if you add in the, I'm sorry, did somebody say something? Beneath Kumar Joshi, do you want to, is there some comment you want to make, some question?
I think there was a Someone has
Inad
turned on his mic.
inadvertent, right?
You can
Inadvertent.
continue, sir.
Sure, sure. Okay. And then, of course, the other thing was that, okay, given a farm, how does the networking happen between the sensors and the servers and the system? And the main standard there is long range radio, but the networking for that is quite intricate and involved. And we found that, hey, I mean, do we really want to go so deep into networking before we even think about what value this system is going to provide? So that was a complication that came up. And then for the animal deterrence, we were like, okay, Ethernet camera, how do we capture the feed and how do we process it in real time, do object detection, etc. That's a complex problem to solve, it seemed. So we figured, okay, this is a potential complication in terms of, the thought that do the least amount of work that can give some real value and put that into a fieldable prototype so that we start getting good signals as early as possible. So with all of this learning, the decision was keep the architecture and then worry about the soil sensors and LoRa, the networking, long range radio aspects later. We have a good architecture in place and let's move forward with this. Then we moved on to the idea of automation. And we said, can we automate irrigation? And for that, what we had to figure out, okay, what kind of solenoid valve we need to kind of procure to kind of play with this idea. And then could we just use Wi-Fi instead of LoRa because it's much easier to prototype with. And the whole idea being that, okay, let us get a bunch of things as cheaply as possible just to validate what we want to do. And of course, cheaply, should be reasonably reliable so that it runs for at least a few weeks. So don't cut corners on up to that level, but get things together to get some real value in the hands of the user as soon as possible was the thought with this ideation step. So then we selected the MCU for the edge components, for the sensors and the actuators. We said, okay, ESP32 is good enough. And then we selected a solenoid valve, selected a MOSFET to turn the valve on and off. And then we started building out the prototype. And the pattern here being, make the ideation prototype real, make the idea real in this prototype, with the intent, because this thing seems to be providing real value to the user, with the intent that, hey, can we take it to a fieldable feature that can participate in the larger fieldable prototype. So then as we prototyped things, we came up with this broad architecture. Now, which maybe I will not go into in too much detail because I don't know if that's of interest or not. But I will just list things here, that there's a client. I mean, there are a bunch of clients that the user can use to interact with the system. You can interact with a desktop client over the internet, or you can use a mobile phone, in your farm to interact with the system. So there's this UI component, and then we have the UI server, and then the REST server where programmatically you can access the server. And then you have this whole messaging layer where you have this message bus where the edge devices through their MCUs can put messages on the bus or receive messages from the bus, because if you want to, for example, turn on the valve, then through the UI server or the REST server, however that path works out, a message gets put um, onto the message bus, and then the appropriate controller will pick up that message because it is subscribed to it, and then turn on that valve. So so that's the general architecture in terms of, there's a server for the UI, there's a server for programmatic access, and there's a message bus where edge devices can listen for things and put things. And the message bus is very important because it's a very reliable way to get data into the system, even if the network is flaky, because they have this quality of service, and it's built for MQTT, the MQTT messaging protocol is built for edge devices in unreliable conditions, reliably putting data into some place where from where it can reliably go into the system. So that's the kind of architecture we came up with. And then we prototyped it. We had this control center where you could pick up a valve and turn it on and off. And then this is the thing happening on a real little prototype farm, not even the hill farm, because the hill farm is like 4 or 5 hours away drive from Dehradun where I live. But about an hour away, we have this school with some farms around, and we've been running programs with Kojo, which is our software for teaching children coding and computational thinking and design thinking, etc. So there we set up this prototype farm with just one bed, where we are playing with the ideas. So here in this picture, we have me sitting here with my mobile up here, and then the server is running on the laptop, and then uh, we see the ESP32 here, and both the server and the ESP32 are on the Wi-Fi. So then the messaging bus, which is also running on this laptop, that's taking care of the message flow back and forth from the MCU. And then we even see the valve here, in the back here is the valve, which is connected to the MCU. And then here I turned it on, so then the water started flowing. So this was like the first test of the things to see how it was working. And then, of course, we had a UI, to tell you that, okay, if you turn the valve on, it has stayed on, there's no malfunction, and what is the current state of the valve, etc. So there's a UI to kind of monitor what's happening with the valve. And the learnings from this prototype were, that IoT valve programming, IoT messaging, system architecture. Potential complications were hey, we knew that our solenoid valve and our MOSFET were not quite industrial grade. They were just components we have, relatively cheap components which we got and we kind of put together. And then the decision from all of this work was that this is a working system with good value because you can turn on the flow of water into the field, and we should definitely build further on it and put it in the fieldable prototype. That was the decision. And the pattern, once again, logic before models. So here with simple logic, uh, and this logic could be, that if reading coming in from the soil sensor shows that the soil is too dry, then the simple logic can turn on the valve to get the flow of things going. Or to begin with, we can leave the control with the human being, and the human being can look at the data in the dashboard and decide to manually turn on the valve, which is still a great improvement over not having any automated way to do irrigation in the field. Okay, so that was prototype 12. Vijay Kumarji, your mic is on.
Yeah. Hello. Hello.
Okay. So the next cut of ideation was, okay, we have some dashboardy thing going, we have some control automation thing going, which can be good parts of a fieldable prototype. So now let us look at decision support for plant health. Is the plant growing fine? Plant disease, does it have disease? Are there pests infesting the plant? Is the nutrition for the plant okay? And then we figured that, okay, one good way to do all of this would be to take pictures and then tap into AI to kind of help us with all of this and to play with this. I mean, that's the idea. And then we prototype and see how well that works out. So that was the 13th step in this process that we were following, which was an ideate step. And these were the ideas we came up with. So the next thing to think about was, again, a divergence where we come up with different ideas. So we said, with AI, what kinds of things can we use? And we came up with a whole list of options. So the first one was that we would create a custom GPT, and inside that custom GPT, we would put in documentation from various agricultural universities, agriculture department, government of India, etc. Put in a lot of information there about disease and pests and growth cycles and things like that. And then we would do a few shot prompt where we would say, okay, here's a picture of a plant, and here are some few shot images of known diseases and plants. Now, based on these few shot images and the description you already have, kindly tell us more about the picture from the plant that we've sent in to you from the field. So that is the custom chat GPT idea. The second idea was second idea was do it yourself. Whatever happens in custom chat GPT, because you have to kind of depend on some provider like OpenAI, and then there's a recurring cost of doing all of this. Then another thought is use an open source LLM and then do the RAG and all of that, retrieval augmented generation and all of that stuff. Whatever the custom chat GPT is doing behind the covers, you manually do yourself. uh, so so note that even if this idea doesn't seem very feasible from the spirit of getting something going quickly, when you're ideating, you don't worry about the feasibility of the idea. Ideation is just about generation of ideas. Later, you evaluate them to see what you want to pursue. So here we were just generating ideas. The third idea was a zero shot meaning, with no training, no examples, you get some piece of AI to do the work for you. So zero shot VLM encoder based classification. So here the very interesting thought, this one, the thought was that with a vision language model, you have two towers. One is a vision tower, one is a text tower, and the vision language model is able to generate common embeddings for inputs coming in from these two towers. So if an image and a piece of text are very similar, then they would, embed and go to a place in a high dimensional space, which is very close together. So if the image and the text kind of match each other, then their embeddings will be close together in the embedding space. So then using this fact, if you have good descriptions of the diseases, if they are nice descriptions of what that disease is like, then upfront you create text embeddings for all those descriptions. And then when you take a picture and you feed it into your VLM, you get an image embedding for that picture which you took in your field with your plant. And then you compare the image embedding against all the text embeddings for all the different diseases that are possible. And then the one that it is closest to, that is the disease that it could be, that it's most likely to be. So that was another thought that another idea that came up. And then there were some others, because we're running out of time, so I will not describe them. The last one was just the traditional machine learning, the pre-Gen AI kind of an idea, which is take a well-trained ResNet or ConNext or EfficientNet or some, good deep learning model, which has been trained on a large corpus of data, and then just do transfer learning and fine-tuning with that model, like one would do without Gen AI. So we came up with some of these ideas. And then we converged on two to begin with. We said, let's go with these two because custom chat GPT 5 and now 5.1, this is a very strong model. So let's see what kind of results we get, so let's go with that, especially given these documents from the agricultural universities and, from the government of India and so on, and the few short examples. So let us see what results we get, and that will give us a baseline. And then this looks like a very neat idea. The zero shot VLM encoder idea. Sounds like a very neat idea, and it's very little work to kind of put into practice. So let us also try this. And then let us see, hey, maybe this can be used as a validation for what ChatGPT said, just in terms of one more extra level of confidence in terms of, okay, ChatGPT is giving this diagnosis and this other piece of technology is giving this diagnosis. So that adds to your confidence or your lack of confidence on what the diagnosis is. Plus, in certain situations, because this is much more efficient, the zero shot open clip prediction happens in like sub-seconds, some millisecond level of latency, whereas the custom chat GPT, especially in thinking mode, takes 50 seconds or something like that. So both options putting on the table was the idea. And then from an AI point of view, there are lot of good factors about these ideas, which maybe, because we're running out of time, I will not go into at this moment. But these seemed like promising ideas, so we decided that we wanted to pursue them. So then we prototyped things and we said, okay, let's build a disease checker using the open clip, the zero shot VLM encoder idea, where we used open clip as the model. So we built a disease check UI for that. And then we built another UI for you capture a photo and then you can copy it to the clipboard, and then you can open the custom GPT, copy the prompt from here, put it into the custom GPT, right click on the image or copy the image and, paste it into the custom GPT, hit, run there. And then the custom GPT has been instructed to give, and in fact, even the prompt says return JSON only. So it gives a very structured response with a diagnosis and a differential diagnosis and all of that. So we did that prototyping. And then the learnings from that were open clip solution shows promise. It's good accuracy, it's fast. Custom GPT is very informative for disease diagnosis and differential diagnosis. Good accuracy, but takes 50 to 60 seconds with thinking mode. Potential complications, lack of good data for good evaluation of models. So we had a little eval set where we tested these things. Because the data sets that we found, we spotted a lot of errors in them, which were messing up the results, of course, because if the input is not what it claims to be, then the output is not going to match your expected output. So lack of good evaluation data. And then, of course, custom GPT diagnosis is not feasible doing time-wise during a field visit because with for example, a laborer visiting or, a technician, a semi-skilled technician going through the farm, he's just taking pictures as recommended by the software. He doesn't have time to do all that chat GPT back and forth and so on. So then the decision that came out of this prototype was build further and then put this into fieldable prototype, gather good data, and of course, tweak the UI here, which is the next thing we will talk about. That was the decision that came out of this. The next step, which was an ideate step, was it's good to do some UI refinement here because just for capturing data in the field, a lighter focused UI is better. And then there can be a separate area for analysis and decision support that can be used later by a user. And of course, in the interest of time, I've not really been talking about the labels that much, but we will revisit them later. So don't worry about that. So then we went ahead and did this UI refinement with prototype 18. And prototype 18A was the photo capture screen was changed so that, the classification option for the fast classification based on open clip is still there just in case the person wants to do it. But this is optional. And then you can capture images and save them. And then from the photo capture area, you can move to the decision support area. And you can see a list of the images that have been captured. And then you can analyze any particular image. And for that analysis, you can classify based on the open clip model, or you can open the GPT and do the more detailed analysis. And then you can save these predictions from the models back into the database. And the learning was that this is a better structure for the UI. And the complication still was that we need better evaluation data to be more confident in our models. And then the decision was build further, put in fieldable prototype, gather good data. Okay, so then ideate 19 was about we need more data. So let's think about gathering more open source data for our problem, which is cauliflower crop cycle management. And then our own data to supplement the above, because we have these farms where we put in cauliflower. So let's start to gather that data too. So even if it takes time, one crop cycle, we'll have something to work with. Then, and these things to build good systems, you always, you always give time to yourself to build decent things. So getting our own data as a starting point with the first crop cycle would be a very good reference point to kind of benchmark the AI. So that was the thought, that we need to do more data collection to make our AI and our decision support richer. Then we thought a bit about, once we get the data, what kind of decision support we can do with that data. So then we came up with this list of things. We can do plant growth monitoring, because in the images the plants keeps getting bigger and bigger. We can use that to run algorithms to see whether logical based or logic based or AI based, to see if the growth is on track, if there's any abnormality in the growth. Plant nutrition, hydration monitoring, plant disease, pests, and nutrition across the whole life cycle. Crop yield, at some point, can you predict the yield so that you can start planning in terms of your profit and loss? This much of crop is going to be there, where is it going to be sold, and so on, and what kind of revenues, what kind of prices, and so on. So we need systematic data capture for the above. And once we have the data, we can start to do all of this analysis. So we want to do data capture, and we want to provide support in our application for the workflow for data capture, so that the data is captured in a particular way that provides value. So then in the next ideation cycle, we said, okay, let us do weekly photo shoots, where we will take 16 photographs per shoot, one long shot of the bed, and then three shots of quadrants, where like a little area where we have 3 plants in there. So the same 3 reference quadrants we're going to have when we're going to take those photos. And then we have 3 reference plants that we select in a bed, where we, one is a good plant, healthy plant, one is an average plant, one is a sick plant. And for each plant, we take these photos. So there are these 16 photos that we want to take. And then we prototyped a UI for it, where you go to this area and it gives you facility for taking these 16 shots. This is yet to go into the field, and of course it looks quite complex. So the other thought is that let's play with this, and if it is too complex right now, it's not the minimum usability threshold is not met, then we will put in a wizard kind of an interface to kind of walk through this workflow. So that is the prototype and the testing that needs to happen very soon. So that is the kind of the case study journey of what we went through over the past couple of months. Couple of implementation notes. Number one is that this library called Gradio is very useful for prototyping AI user interfaces. So if you're interested in prototyping AI applications, kindly do check this out. And then a co-pilot for quick code generation has turned out to be very useful in all of this work, because for a lot of these things, or many of these things, I've used Codex CLI, which is OpenAI's agent offering in terms of code assistance. So they have a plugin for VS Code, and you can install that, and then ChatGPT 5.1 Codex, which is a version of ChatGPT which is fine-tuned for coding, is available to you. And my own experience very strongly was that don't let it do too much, because if it does too much, then it takes things in a direction which it wants to take them, and then that might not align with your vision on the architecture and where you want to go with this. So take small steps, and before you take those steps, ask it to explore the space, so that your inputs as per your expertise can come into the picture. So explore the space, give it suggestions, ask it questions, and then say, okay, take this route, and make those decisions to kind of guide it to do what it wants to do. But even then, be keenly aware of technical debt, because even if it does what you want to do from an architectural perspective, you will find that there are suboptimalities in the code. So be aware that at some point when you want to migrate this prototype from a fieldable prototype to an MVP, at some point you have to take care of this technical debt. Uh, One has to be very aware of that. So those are some implementation notes. Okay, now we come to the third part of our session, which is what can we gain from this, so that when you try to do AI prototypes of your own, how can you benefit from these ideas and these patterns? And let me very quickly run through a high level view of the case study, so that uh, as we were going through this in a fair amount of detail, you might have lost the thread of what happened. So I will just quickly run through this high level thread of what happened in the case study. So we did empathize one, where we talked about the farm owner in the hills context. Then we empathized again and talked about the larger hills context. Then we converged onto the farming context. Then we defined the farming problem. Then we defined the crop management for cauliflower problem that we wanted to tackle. Then we came up with potential solutions for the cauliflower problem that we came up with. Then we came up with uh, the live dashboard general solution idea, then the live dashboard focus solution idea. Then we did a prototype just to get the tech stack going. Then we did a prototype with a basic dashboard with some value with data and logic. Then we came up with automation solution ideas. Then we did a prototype with irrigation automation and the edge architecture with the message bus, etc. Then we ideated on the decision support solution ideas. Then we ideated on the AI options for decision support. We ideated next on the focused AI options for decision support. Then we did a prototype where we did a plant disease check with a couple of AI options. Then we ideated on UI refinements for this previous prototype. And then we figured that, we wanted to change the UI a little bit, refine the UI. So then we did a prototype with a separate plant disease check area and a basic decision support separate area, where the two AI options were integrated. Then we ideated on data collection for richer crop cycle management and decision support. Next, we ideated on the UI for data capture. And the last prototype was, okay, what is the UI for data capture that is going to help the person in the field capture the kind of data that we want to capture to do richer decision support. So that's the case study that we went through. And of course, just as a recap, all of this is in the context of this farm that we talked about, where we are basically talking about the four solutions that we see here, which are, a dashboard, automation, and in fact, animal deterrence we didn't really get into, and then analysis and decision support. So three kinds of solutions are the things that we looked at over the course of this case study walkthrough. So this slide just recaps the whole space. And then I want to talk about these 5 patterns once again, which is the potential takeaway for you if you're building a prototype for an AI application from scratch. So these are potential takeaways for you. So the pattern 1 is data/logic before models. And in our case study, we saw this in the dashboard workflow and the data capture workflow. And the takeaway here is that for your AI prototype, ask what's the simplest useful thing I can build with data, the dashboards or rules before training any model. Is there any simple thing I can get going before worrying about AI? So that is the first pattern. The second pattern is this whole idea of, how does design thinking fit into prototyping? So ideation prototype versus fieldable features which go into a fieldable prototype. So for your AI prototype, ask which small experiments can I run now and which 1-2 ideas look promising enough to flesh out into a real feature in the running system. Okay, and in our case, it was the valve automation workflow. Pattern 3 was how much importance should we give to the UI? To coming up with basic usable UIs versus worrying about very, very, nice UIs, pixel perfect UIs. And the basic thought there was that in the beginning of the process, in the early phases, usability and learning is important. And once the functionality is nailed down, then the UI fidelity can increase. That was the experience that we had. So for your AI prototype, you can ask, what is the minimum UI that makes sense? And let's real users try it out and give feedback right away without worrying too much about the perfect UI. The next pattern was edges before the center. And here the idea is that, you get a full workflow of the flow of data going in your system, and you get your architecture in place. You become confident of your system as a runnable thing that can be a fieldable prototype for a period of a few weeks at least. So then through this pattern, you ensure all of that. And in our case, for example, the valve automation workflow met these criteria, and it helped us put the system architecture with all the messaging bus and everything in place. So for your AI prototype, you can ask, how does data enter, flow through, and trigger actions in my system, even if AI is turned off, So you just worry about how's data coming in, what's coming out, and what the architecture of the system is. And then finally, the fifth pattern, which is borrowed brains before custom models. And there the basic idea, of course, is that which pre-trained model or API can I plug to get a baseline before I even consider training my own models. And we saw that in our case, we kind of did a custom GPT, and we used OpenClip to establish that baseline. So that is pattern 5 that we saw in our own little journey. But even beyond all of that, the message I want to leave you with is the following, and we saw this earlier too. Please don't get hung up on the terminology. Please don't get hung up on the precise patterns. Just get a sense of what these patterns talk about. Because at the end of the day, design thinking is a way of coming up with ideas and seeing whether those ideas are any good from the perspective of a user. Okay, that's the core idea. And if you stick with that and use your common sense, you will be good with design thinking. And then backing up, I want to talk about one other aspect of things, which is even as we are steadily moving forward with our own intelligent agriculture solution, which I spoke to you about, our current work is also a great learning ground in the space of education. And we do plan to use our work in the space of AI education and open source software. We plan to open source all of these things. Even as we develop our Agri AI initiative. So I'd like to extend invitation to all of you who might be interested, because I understand that you're all from universities, your faculty at various universities. This is, after all, an FDP. So if you are interested and you want to, get a few students involved in small little pilots to explore various aspects of things, the AI aspect, the IoT aspect, the architecture aspect, the software development scalability aspect, the database aspect, or whatever, you're very welcome to get in touch. And if you do, maybe we can do some interesting things together. So I hope to hear from at least some of you. And I'd like to give credit to our farm partners. So Sri Timli Trust is the farm in the mountains, which I started this whole case study discussion with. It is located at this village called Sri Timli in the Pauri district of Uttarakhand. And then we have Mother Dream School in Badripur, which is in the Harbatpur area, close to Dehradun, maybe about an hour away from Dehradun. So these are our two farm partners where all of these experiments are going on. With that, I kind of end my talk with once again a call for collaboration. If you want to explore things with zero commitments, just if you want to hang out and explore ideas and ideate and use a design thinking approach to generate ideas and see if they're any good, then I'm very open to having such discussions. So any questions before we call it a day? Let me check out chat. So why is okay, so let me go one by one, right? So, okay, that's good. So there's some good appreciative thoughts. So I really appreciate that. It's good if you found some value in the thoughts. Okay. So some good thoughts. Okay, then there's some, don't take it in some another way, but let's see. Why have you called your foundation as Kojo? A foundation is called Kogics Foundation, and it's because it's meant to align the logical perspective with the yogic perspective. So through logic, go into the space of education, right from class 1 and class 3 and class 6 onwards to the school education, now university education with AI education initiatives. So logic and then meditation to kind of ground things in the act of being, because that is a very important component in this coming age and day of AI, that how do you tap into technology as a good human being? So the meditation perspective comes from there. And Kojics is like a combination of this logical aspect of things and this yogic aspect of things. So that's the name of the foundation. Second out. Okay, why did you choose cauliflower? So it's a good cash crop. And I can go into my slides because the agri people know more about this than me. So, but from what I remember, it's a good cash crop. Its timing is such that when it's not available in the plains, it can be grown in the hills. And then its crop cycle is such that there's a certain level of complexity for that head to kind of grow properly. So if things go slightly wrong, then that head is not going to be good, and then the whole crop cycle is going to be very suboptimal. So then there's a lot of scope to use algorithms and AI, etc., to make sure that the growth cycle is going well and happens nicely. And then because of the season difference between the hills and the plains, there's a good marketing opportunity. And then it's got a good price. So then from a viability perspective, also it's good. So for some of those reasons, we chose cauliflower. Ginger and tomato, those are definitely things that have been mentioned, and you have to pick one, right? So there was a brief discussion about this thing, and this was also driven to a certain extent by the reality on the ground. So the discussions were always grounded in reality. So in the farm, they were already growing cauliflower and running into some of these problems. And then in the big scheme of things, there didn't seem that much of a difference between cauliflower and tomato in terms of value added. So then we just went with cauliflower. Okay. It's wonderful to kind of see some of the appreciative comments. I'm very grateful for that, and I hope the session was useful to all of you, to give you this perspective on things. And with that, I hand it over back to you, Suyash. Are any of the organizers here, or should I take the liberty of bringing this session to an end?
Thank you so much, sir, for your session. I would like to extend my heartfelt thanks to Mr. Lalit Pant sir for joining us today and sharing his knowledge, expertise, and time. Thank you once again, sir, for making this session a remarkable learning experience. Thank you, sir, for your time.
My pleasure. It's been a pleasure being here and sharing ideas with all of you. I see a comment saying send feedback link, so I hope the organizers will take care of that. Okay, so with that, I wish you all a good night and hope to see you around somewhere. Bye.
Sir, feedback link.
It will be shared in the WhatsApp group. You can leave the session.
Feedback link, ma'am?
Yes, the link. I will share the link.
The WhatsApp group.
No,
Otherwise, chat.
I will share the link here only.
Okay, sir. Okay, sir. Thank you.
Hello. Hello. The link is shared here. I will share again in the WhatsApp group also, as some of the participants have left. No problem. We can share in the WhatsApp group.
Well, you understand him. He had a different way of talking to human beings.
Greetings, citizen.
I was chock full of lots of old type gadgets, cool moves. You can learn a lot from it, man. Hold up a second. My teeth missing, and the legion of Zoom has something to do with it.
Dear participants, you can now leave the session. You can save the link. I have also shared the link in the WhatsApp group. You can leave the session now.